So the vapor pressure, the other properties of liquid and structural difference between solid, liquid and the gases. So let's first talk about the vapor pressure. What exactly is it? So you know when the material structural is when you have a materials here. So let's say we have a room that, let's say, this is a liquid, and then the mole in this liquid is, here, here, and here. So when the moles is, always want to get attached to each other. So there's a bone here, here, a small bone here, here, everywhere. There's a small bond between the moles that want to get attached with each other. So why they want to, what exactly that they want to accomplish by attached to each other? And yeah, they really want to get free. And yeah, that's the simplest how I can explain it to you. So in this room, the liquid here is going to vaporize to gases. Then the gases also have the molecule, so here, and they also have want to attach to each other, but just in lower kinetic energy. So they are have much of kinetic energy, so they are gonna, when they are gonna vaporize, they are gonna have a kinetic energy, and then when they are turned again into the liquid, they have a much less kinetic energy from before. Then yeah, this exactly is the vaporized pressure. So when the liquid here want to vaporize, they are have a some kinetic energy that push them to attach to each other. So when they are got to vaporize, the kinetic energy is way lower when from the liquid form, but yeah, the kinetic energy is very less from the liquid form. But who is decided the kinetic energy for each molecule here? It's the pressure, and that pressure is called the vapor pressure. Vapor pressure. So with, just like the subject that we are talking about before, when with the higher temperature, then the higher the mole is going to move, right? So the same thing is does happen here. So with a higher temperature, also gonna comes with the higher pressure. So when the pressure is higher, it's gonna be more harder to the liquid to vaporize. It's gonna getting more hard than before. So that's the vapor pressure is talking about, and that's the basic material. Yeah, basic subject, I guess. Then, why do tear want to escape? The liquid is want to attach to each other, like a mole. We have mole here, and the mole here want to attach to here, as well as this want to attach to this. And why do they want to do that? And yeah, that's exactly what vapor pressure means. You are gonna studying about the molecular again, the some kinetic energy, the liquid, solid, and gases form for the material, and yeah, why, and some physical theory of the temperature, pressure, and yeah, just like the previous subject, with the higher temperature gonna comes with the higher pressure. But I'm gonna show you another example. Whoa, it's getting a mess here, right? It's okay, no problem. I got much of paper here and much of time to explain it to you. So here we comes the another box. No, not actually a box. So vaporized pressure is talking about the material, right? The molar, right? And then the molar is want to attach to each other. So the reason why they are want to attach to each other, it's because they are wanted to get free. And yeah, that's why the molar moves. And yeah, that's what the kinetic energy means. So here we have some fluid here. Yeah, this actually has a a chart that this is at the atmosphere, and this is just the temperature of the substance. Yeah, I guess you understand what I'm talking about. So let's move on to the another. We have the difference between the solid form. I maybe just get rid of this first, right? So I waste a lot of papers here. So we are talking about the solid form of the substance, the liquid form. So I'm not very good at drawing, so I'm sorry. And the gas form, the solid, liquid, and the gases. You got what I mean? So what the difference between this? You all already know the difference, right? The solid is something that you can touch. No. The difference is actually in the atoms, in the moral. So when it comes to the solid, I'm really gonna waste a lot of paper here. So just this will do. So it's come to solid form. So the matter in the actually in the substance is very close. So we have a box here, and this is a solid form. And yeah, the atoms, the molecular and in this solid form is very attached to each other. So they are hard. Yeah, that's why they are hard. They are, you can touch it, and yeah, that's why. So they are really close to each other when it's come to material, liquids. They are the hardest form for the every substance. Hardest form. Then let's move on to the liquid one. Alright, this won't do. Oops, I'm probably getting out of the paper, so I'm gonna getting some more. Okay, here I got the paper, and let's continue the explanation. So when it comes to the fluid, fluid form, the matter between one in each other in the fluid form is not very close, just as the solid one. So look right here. Yeah. When it's come to the solid form, they are very close to each other. They are just like, they are very attractive to each other. So when it comes to this fluid form, they are not gonna so attached to each other. They are not gonna be so close. So what does that mean? That let's say that we have some liquids here. So unlike the solid form, that the material is very close, the fluid form is, just not so close, but attached to each other just enough to maintain the form, not like the solid that very close. The fluid form is just as close as they can maintain the fluid form before vaporized to the gaseous form. So I'm gonna write it here because maybe you won't hear it very well. Then yeah, the liquid form is the form that just enough attractive to each other to maintain the form. So they're gonna, you know, literally gonna vaporize anyway, but this form is just enough. And yeah, here we comes the, I can use this, but this will do. This will do. I'm not gonna waste any paper anymore. So the last one is the gases form. So the gaseous form is very different from the liquid and the solid form. When it comes to gaseous form, they are not even have a shape. You know gas, right? Gas not even have a shape, right? And yeah, if the solid form here is have a very strong bone to each other, and the fluid from before just enough to maintain the shape, then the gases from don't even have a shape anymore. So when it comes to gases, the material here just gonna fly away whenever they want, whenever winds come to it. They are, they are have a bone here, but they are, still attractive, but just not attractive, very attractive to each other. So it just, the bone is from the, just from the chemistry ideal between them. So that's it. That's the solid, fluid, and the gases form explanation. So if you have any question, please put down in comments and I will answer it if I call. Thank you.